Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Rustam Memandarov, who will be presenting on the topic of 5 tips on creating modern cloud native applications. If you have any questions for Rustam as we move through today's presentation, feel free to ask them in the chat or click on the Ask a Questions tab. Without any further delay, Rustam, over to you.
Thank you very much. It's a great pleasure to be here today on actually it's a Pi Day today. In case you haven't noticed like I did. It took me some time to actually realize it was a Pi Day. So it's a kind of cool day to do this presentation. And thank you for having me. Um, I am streaming. I'm joining you from Oslo, Norway, and um, good morning, good afternoon, good evening to wherever you are. If you want to write where you're located right now, where you're joining in the chat, feel free to do so. Today, I would like to talk to you about this thing that people talk about a lot. They talk about cloud, they talk about cloud native applications, and I want to take a little twist on that and try to say, what actually makes a cloud native application a cloud native. And a few words about myself, just to introduce myself. So like I said, my name is Rustam. I live and work here in Oslo, Norway, work for a consultancy company here called Computas. I'm a Google developer expert for cloud and also Java champion. So, I mean, the cloud and Java is kind of things that I do work quite a bit with. And I work also a lot with architecture. So this is a bit of a digest of the questions I get as a consultant, as the speaker at the conferences and stuff like that. And also a bit of a mix of things that you should be doing. You do not need to do all of those things that I'm going to mention, but the point is to doing at least one of the things I'm going to be mentioning will, at least in my opinion, will improve your application as well. So let's talk about cloud native applications. So first of all is that I want to start with what is actually modern software development? What is this cloud native applications? It's kind of called app modernization. It's called modern software development. It's called cloud native applications. There's different names for the same thing, but in general, you see you can separate it in 2 different categories, those applications. So typically there would be some kind of applications that we're running. It can be something, I don't know, a website or a web store or some kind of microservice application doing something, with a front end and back end, or maybe just a back end with some kind of API and stuff like that, serving some kind of data, doing something that you would like it to do. The other one is a typical modern applications that we need nowadays, is something that can actually digest data. So typically applications doing data pipeline, data processing, and all these things. They are very different in a lot of sense, right? They are with the regular applications, I call them regular applications. The first category is the important thing is typically would be performance, so they're quick, they are available, all these kind of things. With data pipeline applications, processing and chewing through data and doing some stuff with the data, it's a processing time, obviously, is a thing, right? Because there's a lot of data coming in, you need to process, you don't want to lose data, you don't want to do these things and everything. And I mean, it's still a lot of things, those 2 categories, they still do have a lot of things in common. So what is typically in common is that they have to be scalable. They have to be able to, elastic. They have to be able to react to changes, to react to a number of users coming in, scale up, and then whenever you don't need them, scale down. Because otherwise, if you'll be running those in some kind of cloud data centers on-prem or anything really, you need to be able to do this scaling, because in all, at the end, it will cost you resources, or it will cost you money, or both, really. Because I mean, if you're running on your own hardware, you want to use that hardware for other things. If you're running it on cloud, it will definitely cost you money running many instances of that application while you don't have enough users, and so on, so on, so on, right? So you want to be those applications, no matter what they are, you typically have to make them scalable. You make them both isolated in a way, but and also still have loose coupling. You want to make them reproducible and repeatable, and you want to do it in a unified way. So this is kind of the idea, right? This is the types of applications people come to us and say, hey, we want to build either a regular application, people call them regular applications, or kind of data intensive applications, data processing applications, right? So both of those types, they have a specific kind of business needs. So I want to talk a little bit about the why part, which is like, what is this thing? I mean, why do we want those modern applications? What's the point of doing that? Why can't we just do it in a different way like we used to do? I mean, back in the days when I started working as a developer, we would just, you would create an application. It would have some kind of server, backend, database, something. It would have some kind of front end. Typically, sometimes it would be a backend rendered that front end and sent it over, JSP, JSF, all those kind of things. I don't know, maybe even PHP, but we don't talk much about that, right? At least as a Java devs. But there would be something rendering and sending some data forward, and then you would just deploy it on a server. It would run there. If you needed more, if you would have more users, you would have more loads, you would just get a beefier server, and then you'll just deploy on a bigger server, and you're good, right? Nowadays, things are a bit different. Right now, we scale in a different way. Now we have this thing called microservices. We don't have things like, I mean, we don't have to think about certain things of like scaling of the servers and creating beefier stuff. But now we have to do microservices instead of monoliths very often, but there are still things that our customers, people asking us to develop applications, or whoever asks you and pays you to develop something, or even if you developing for yourself, for your own startup or anything, you're concerned about certain things. And those things, at least the main 5 things that I've seen a lot, is think that we want it to be fast. The applications obviously have to be fast because there's a lot of applications, there's a lot of competition, there is a lot of maybe competing resources, competing products out there. And if your application is not fast enough, the users might go to something else. So you want to be able to create applications that are fast. But there is another aspect of this speed thing, and that is time to market part. And that is an interesting, different story, because while you can make your application faster by just making it a bit more beefier and cooler and bigger, you can actually you still will with the older approach, it will take a longer time to come to this time to market span of time. It will take you longer to develop, because you have to rebuild the whole thing. You need to create a new version of your application. You have to take down the old one. You have to redeploy it, and so on, so on, so on. So time to market is an important thing. Now you want to be able to create new features, make them available, and make them available to everyone as soon as fast as possible. So that's the speed part. And then there is another thing. Then there is this thing of agility. And agility is kind of related to speed, but then it is more related to responding to change. So say you want to deploy a new function in your application, so like a functionality, or maybe you want to deploy a newer version of a part of your application, of a little service that your application is using, because typically you would have some kind of microservices or some kind of set of smaller services talking to each other. Now you don't have to replace everything and restart everything. Now you can just do it with a tiny little piece of it. At least you want to do that. So that's what I mean by agility and ability to respond to change without users noticing too much of a downtime. The other thing, the third thing, and it kind of goes, those five things that I'm going to mention now, they go into from, at least I try to sort them from the most obvious to a little bit more obscure one, or at least a little bit less obvious. So the third thing is reliability. So reliability, what do I mean by that? Well, I mean that your application has to be reliable. It has to be there when users need it. And how do you do that? Well, you typically should think about scalability. So your application should be able to, grow in size. I want to say grow in size, but in reality, it will be growing in numbers, because you will have typically, we'll talk about that later, but typically you will have a bunch of uh, small containers scaling. So you create more instances of the same application. And depending on the number of users, for example, right? Or depending on loads that it has to process, or some other kind of metrics. And it also has to be available. So you also have to make sure that it is safe. You have very local applications, you don't really need to think about availability like a global availability. But if you're developing an application that should be available all over the world, maybe you want to also think about creating different clusters in the different data centers, different places around the world, because then you'll have a smaller response time to your application and smaller lag and all those things that closer ping or lower ping to your application brings to the table. So that's the reliability part. Then there is this thing called resilience, which is, it shouldn't be confused with reliability, but it's again relatively connected thing. And resilience is about being able to respond to something that is not supposed to happen, but still handling it in a kind of nice way. It can be errors, it can be external outages or something like that. It can be also way of telling that your application is about to uh, do something wrong or do something bad without users noticing it. And that is a part that comes. So the first thing that I talked about, responding to errors, that's a fault tolerance. The second part, the last thing I said, it's about observability. So how do you make your application to actually tell whatever it is running on, how is it doing? What is happening inside the application? So maybe you want to expose some kind of metrics. Maybe you want to expose, I don't know, say CPU usage or memory usage, depending on what your application is doing, or number of concurrent users that are on that specific container, on that specific application instance. And the last thing that is unfortunately quite often forgotten, but still very, very important part, it is the security, and security on many, many levels. So we still need to think about security. We still need to make sure that our applications are secure. And I also put that into this bucket of resilience, because, hacker attacks, DDoS attacks, and all those kind of things, you need to be able to handle that as well with your modern applications, because, well, your application and they all live in this modern current world where all those threats are out there. By fault tolerance, by the way, probably I should mention that as well. You should think about how does your application handle internal errors. So if something wrong happens, if something fails inside your application, what do? Do you just throw a stack trace at a user and just hope for the best? Probably not the best option, right? So you need to think about that. But also, you need to think about what happens with external errors as well. If you're using a service that you have no control whatsoever over, and it still fails, what do? You throw again a stack trace at the user? Probably not a good idea. Do you do some other tips and tricks? Well, maybe. And then we'll talk a little bit about that at the end, or soon. The other thing that usually the business needs define, the users ask for, or the customers ask for, is this thing, and it's actually very often misunderstood, is the thing is the concept of avoiding lock-in. So avoiding vendor lock-ins. That is a kind of funny thing, because people often take it very literally. Because, for example, let's say you have a cloud service, a public cloud. That public cloud service has a database offered as a serverless feature, or as fully managed database solution. It doesn't matter what cloud you're running on. It can be your own on-prem solution, or it can be some kind of public cloud provider. It can be any public cloud. But the point is, you have a cloud service and you have this fully managed database service. A lot of people, I've seen this happen way too many times, and that's why I'm mentioning it. They would go, well, we can't use that. We're just gonna, you know what? We're gonna use that cloud service, but we're gonna create a VM, virtual machine. We're gonna install that database solution onto that virtual machine, and then we're gonna use that. And then you would go, but why? Why do you want to do that? Because this is not the cloud way of doing that. This is how we used to do. Now it's different. And then they would be like, well, because we need to avoid vendor lock-in. And then, I mean, you can't say they're wrong because you don't know the premises. But if the premises is that managed database solution is actually based in open source, it's fully compatible with open source and alternatives, or say it's Postgres or MySQL instance just managed by somebody else, then I think you should actually go for that, because it will be managed by somebody else. You don't have to think about upgrading it. You don't have to think about making sure everything runs and optimize it and restarts, taking backups and all those kind of things. It will be done for you more or less automatically, depending on the solution that you're using. But if it is a specific to that vendor, super locked in kind of database, then you probably maybe should look for alternatives if the vendor lock-in is important for you. But my point is that I see a lot of people trying to avoid vendor lock-in and calling everything that they can for vendor lock-in and being like super scared of that. But that's not the point, because we should try to actually utilize what the cloud age and cloud native applications give us. And one of those things is having that platform of a lot of people doing a lot of good work to make that platform work. And again, it can be any kind of platform. It can be hybrid, it can be public, it can be private cloud, whatever you want it to be. Speaking of that, I want to talk a little bit about what is this thing actually. And by that, I want to talk a little bit more about what I mean, because I threw already terms like public cloud, private cloud, on-prem solutions, and all these kind of things at you already. And if you're not familiar with that, I probably should say a few words about that as well. So the scalable applications that we're talking about, these cloud native applications we're talking about, they don't have to run on a cloud. It can run on your own machine. It can be running on your own laptop. It can be running on your on-prem service. It can be run. But the thing is, making them cloud native simplifies a lot of things. It doesn't mean you have to run on the cloud. It also does not mean that it has to be fully cloud-ready things. It's actually, without going to the cloud, you will see a lot of benefits that we'll talk about in a bit. But so, types of clouds. Types of clouds is public or private. There is a lot of them. There is, Google, Azure, AWS, a bunch of other providers. There are providing public cloud services. There are some private cloud services because some people just create their own cloud, where some companies, so people, they create their own versions of that. They deploy it there, and they use that for various reasons. It can be privacy, it can be data laws, it can be regulations, it can be all kind of things. Then there is a thing called multi-cloud. Multi-cloud is a different providers of a cloud service. So say, for example, you want to make your application super resilient. So if one of your cloud providers goes down for some reason, outage, somebody, kills a cable going into the database, data center, or something happens, power outage, many reasons for things going wrong. But if something happens, you might want to create an application that is totally and fully 100% resilient. You might want to rent a capacity or deploy your application onto two different cloud providers. So then if anything happens to the infrastructure of one, your application is still running. We've seen examples of that before. I mean, we've seen some smaller cloud providers having a fire in their data center and just everything going down for many of their customers, because, well, they thought, well, I mean, it's in the cloud, how bad can it be? We're just going to deploy it here and just let somebody do all the job for us. And well, one way of doing that, a normal way of doing that, a less expensive way of doing that, it would be to try to spread your application between different zones if your cloud provider has it. If you don't have it, then you go multi-cloud. You actually deploy into different cloud providers and you route the traffic between those depending on different factors. So that's multi-cloud. And then there is the last thing that people confuse often with multi-cloud is hybrid clouds. And hybrid clouds is a different kind of thing. It's almost the same as multi-cloud, but not really. It is a cloud plus on-prem services. So sometimes, like I said, there are many reasons for doing this kind of things, but very often you would see reasons like regulations. So, for example, EU regulations that say sensitive data cannot leave the premises of EU. Then you would go, either we use it on the data centers that are in EU, or if it is super sensitive and can actually not be there because there are some other regulations that prohibiting us from doing that, then you might actually create your own data centers, or you actually keep the data or keep some processing or whatever that would be on your own servers, and using cloud services to do some other stuff. For example, serving the front end or serving the whole application without that sensitive data, with serving that sensitive data out of your own on-prem solutions. It can also be things like hardware requirements. So say you have an application that runs on a super specific, very fancy GPUs, or needs a specific kind of hardware like, I don't know, TPUs or something like that. Well, then maybe you need to have a hybrid cloud again. So most of the things that are running on the cloud, but some of the hardware is not available in the cloud, so then we're going to put it on our servers, we're going to deploy it there, and we're going to serve the output, the results, or whatever to users through the cloud or through some other ways of doing that. So there are three different ways of creating those scalable applications. And again, like I said, I'm going to repeat it again because it's kind of important. You do not have to put your application in the cloud. It can be fully on-prem solution as well. All right, so we talked a lot about cloud native this and cloud native that and all this. What is it actually? That's another thing that I want to talk about, because now I want to pull a few definitions in. And now we talked about what kinds of cloud is. Now let's talk about what actually what it actually cloud native means. And to do that, I actually have a definition of cloud native Computing Foundation. And their official definition of cloud native. And the link to the official definition you'll see at the bottom there. And yes, I know it's a wall of text. To stop you from reading all that wall of text, and by this time you probably stopped listening to me, you're actually reading that. Stop doing that. Stop reading it. I'll help you. Don't worry. So I have highlighted some words that are important here. I'm keeping the text, but I'm highlighting the words. We're talking about scalable applications. We're talking about public, private, hybrid clouds, and so on, so on, so on. To actually make it a little bit even easier for you, I did remove the rest of the words, but now you are actually getting a gist of what we're building. If you look a little bit closer, you can even group these words in different categories. And the categories are that you have seen in the header earlier. I don't know if you've been, uh, if you noticed my headers that I used so far, I actually so far I used this what and how and why in different places. So what are we building? Well, it's a scalable applications running on public, private, or hybrid clouds. Okay, how do we do that? Well, we're going to talk about how in a second. And why do we want to do that? And this is the business needs that we've been talking about, right? Well, because we want them to be loosely coupled, because we want to deploy new versions so fast and quick, and being able to be independent from each other and all that, loosely coupled. Resilient, we talked about resilience. Manageable, observable, with robust automation. We didn't talk that much about automation. We'll do so very soon. Um, Responding to quick changes, so frequent changes, predictable, and minimum toil. So minimum toil goes kind of hand in hand with robust automation as well, because if you automate a lot of things, you don't have to spend a lot of time doing it manually. And again, going back to the way I started my career working as a developer, when was that? Like 16, 17 years ago, it was a lot of toil. We would have manual procedures, we would have documents describing how you would deploy applications, how you would do that. You need to maintain those, you need to follow those, you need to follow manually all the steps. And if you just forgot about one tiny little step, one tiny little dot, one tiny little space somewhere, you would be in trouble. You would be like, what's happened? So automation is very, very good for that, because computers, they're good at doing mundane, boring tasks. We humans are not so much. I mean, we might do it sometimes. Some of us might even enjoy doing that, but we're still prone to doing some smaller or bigger errors. A lot of misconfigurations, a lot of outages that we've seen online in later years is also very, very often are made by a human kind of error, configuration error. Somebody's forgot to do something, somebody wasn't careful enough doing something or something like that. Computers usually don't do that if you tell them exactly what needs to be done. So robust automation. Okay, so that was the cloud native definition, right? Now is the actual 5 tips that I have been promising to you in the beginning of this presentation. And that is those 5 things. So how do you make your application cloud native? Because now I hope I sold you the idea of why do you want to do cloud native. I hope I sold you the idea what is that thing is. And now I want to explain how do you get there. So how do you get there? Well, first thing, kind of obvious. Again, they go from most obvious to a little bit less obvious. And the first one is loose coupling, because again, you want to have it independent as possible from the different parts of your applications. We talked a lot about this in the last some years, last quite a few years actually. And it was, the splitting up the monolith talks. How many of you have seen those? How many of you have seen tons of those talks? And this is the kind of the splitting up the monolith is the result of that loose coupling thing, right? Creating microservices is cool and nice, and everybody talks about that, and it's like super modern and super in right now. But it comes at a cost. It comes at a cost of thinking about architecture a little bit more than you used to with monoliths. Probably. I mean, if you've been thinking a lot about architecture, developing monoliths, good job. A lot of amazing people and a lot of amazing thoughts went into that, and they spent a lot of time doing that. This was great, but with microservices, you still need to do a little bit more. Now you need to think about how those services would communicate through what formats, what different protocols they would use, and all those kind of things. So it comes at a cost of designing a different kind of architecture, thinking a little bit more about architecture. It comes at a cost of thinking about APIs, because typically you would have some kind of REST APIs, GraphQL APIs, some kind of APIs. You need to think and plan those. It also typically would involve some kind of service mesh. There's a lot of different ones out there. Probably the most talked about is Istio, but it's not the only one. There is a bunch of others. But still, you need to think about how data is thrown back and forth between services. Do you encrypt your data? You should. Do you use things like zero trust, for example, to make sure that nobody can listen to your stuff? Well, you should. How do you do that? How do you make sure that you have correct certificates between your services and they can actually talk to each other just over the network? How do you create your network? There's a lot of things that you need to think, and this is the cost of doing that. But the point is, if you create loose coupling, you will have a little bit of cost, but you will have also a lot of gain. You will have a lot of positive gain in a way that you can redeploy services independent of each other. You can create a different updates and upgrades of different parts of it. You can even use different programming languages. You write one in Java, the other one in Kotlin, and the third one in something else. You can actually do that as well, which can be fun to some extent, but maybe not go crazy with that as well. But that's a totally different story. So the second thing, let's go to the next one. So the second thing is creating containers. Containers is nothing new. They've been around for quite some time. A lot of people talked about that. A lot of people put a kind of equality sign between the word containers and Docker. It doesn't have to be. It can be other kinds of containers. But the point is, actually, speaking of equal signs, a lot of people say they talk about containers as a reproducible something, right? They often talk about reproducible builds, but actually, well, it's a reproducible build. Now I can actually build it here and there, and it will be the same. But it's not only that, it's actually also about reproducible deployments, because you know that you've built that container. That is one big artifact. You can scan it for security. You can scan breaches and security holes and all this. You can scan it for a bunch of other things. And you can let it go through your CI/CD pipeline as one big chunk. And it will go all the way to production, and it will actually bring you not only reproducible builds, so you can build everywhere and it will be the same, but you also will have a reproducible deployment, which is a very nice thing. So now nobody has an excuse of works on my machine kind of thing anymore. So now if it works on my machine, it should probably work on your machine as well, as long as we have similar architecture, underlying architecture for running those containers. And you can even make it portable in between different things, right? You can run it on a Docker, Podman, different Kubernetes, whatever you might want to run it on. So it's cool. It gives you also the ability of making things portable. So if something goes down, if something breaks, you can easily deploy the same container to some other machine, some other platform, whatever that is, with hopefully no modifications, or maybe smaller modifications. So that's that, right? We talked a little bit about automation already. Let's talk a little bit more about this. Oh, actually, containers. One thing to mention about containers is that also it will help you with avoiding vendor lock-in, in a sense that when you deploy your applications to a very specific application server or specific platform, then it will be very hard for you to move to something else whenever you want to do, or if you want to do that. If it's container, it will make it easier. It's not going to be guaranteed just grab your container, run somewhere. Maybe you'll need to do some small tweaks to it, but it will be easier to move because everything is kind of is isolated in a tiny little box. So automation. Automation is a good thing, and you should automate all kind of things, all that you want, and you should automate some more after you've done. When you think you've done automating, take another look, try to automate some more. And by automation, I mean automate things like deployment, automate things like testing, automate things like all kind of testing, really, because you have different levels of testing. You can do like unit tests and static code analysis tests. You can do security vulnerability kind of tests. You have all kind of things that you should think about, and you can and very much should automate as well. Why do you do that? Well, we talked a little bit about that as well. You will save time. It's kind of boring to do the same thing over and over again, but it's also less prone to errors because, again, like I said, computers are good at doing boring stuff. We humans are not so much. And it will reduce the amount of toil. That means you save time, you have less errors, you have less probabilities of errors. If you want to do it gradually, because a lot of people come to me and say, look, we don't know where to start. We want to do all of those things, but our budgets are not enough. Our project managers don't want to let us do that, and all these kind of things. And then I would usually say, try to do that. Try to start with the things that hurt the most, that are often low-hanging fruits, relatively low-hanging fruits, but still give you a lot of value. So actually, people telling you what to do or asking or paying you to do things actually see the results of that and ask you to do more of that. So that is a kind of tip. Start where it hurts more. Automate things that are usually failing the most. Automate things that are the most boring things that everybody hates the most in the project, or whatever. Just start somewhere that gives you the most value. So that's automation. There are different tools for different kinds of automation. There is a tools for doing automation in a sense of deployment. There are tools of doing automation of creating infrastructure as code infrastructure. So there is things like Pulumi, there are things like Terraform, there are things like some deployment scripts and CI/CD scripts to do this automation of builds. There are different plugins that can be pulled in by that automation that do the automated static code analysis, the dependencies, checking licenses, checking a lot of things that you can actually automate and make your life easier, checking security vulnerabilities. I mentioned that already. What else? Static code analysis. You can do a lot of things there. You can automate a lot. Just make sure that you don't go overboard all at the beginning. Just start small, add a little bit and a little bit, and see what gives you value and stick to that. Okay, so that's automation. Let's talk a little bit more about resilience. Resilience is a funny animal. We talked a bit about that already. The point is, make sure what happens when something fails. It can be something inside your application. It can be also something outside of your control. What do? Do you want to just, let your application fail and die and just lie and crawled up on the floor in the server room somewhere and just be in full panic and go full kernel panic thing? Well, maybe not. Maybe you want to do it gracefully. Maybe you don't want to expose, definitely you don't want to expose your stack traces to users. Maybe you don't even want to say that something went wrong. Maybe you just want to say, hey, you know what? I received your request. We're going to handle it. Thanks. I'll tell you when it's done, maybe. Or maybe you want to do, maybe you want to fail over to something. And a lot of libraries and a lot of frameworks actually give you opportunities to do that. So there is things like exponential backoffs. There are things like retries. There are things like fallbacks. There are things like retries of a failing service. And because all of those things, obviously you can write them by hand, but there is a lot of logic that goes in there that you don't want to rewrite and write actually to begin with. Because, for example, let's say, what happens to your application if something goes down, and one part of your application goes down, and then one other part starts retrying and hammering that other part with requests. There's a lot of requests coming in. It fills up the network, fills up the application server, fills up everything. Everything grinds to the halt. You don't want to do that. You want, for example, to introduce exponential backoffs. It will try often in the beginning and will kind of slow down the retries, not to DDoS your own applications. That's a simple example for that, right? There are things like that that will help you with all this. And I'll talk a little bit more about this in the context of Jakarta E and other Eclipse Foundation things that are under the umbrella of Eclipse Foundation. So yeah, that's the fault tolerance. Observability. Observability is the ability to tell you how your application is doing based on some specific metrics. To do that, you need to be able to expose those metrics. And to do that, again, you need to be able to easily expose those metrics. You don't want to sit and write all that. And there is, again, a bunch of libraries and frameworks that do that. We'll talk about that later in a little second. Last thing is serverless. And serverless is a kind of, again, a little bit obscure and a little bit slightly misunderstood kind of thing that I see going as a pattern, as a kind of trend through the time lately. It's people think that, oh, to do serverless, we need to run on the cloud, or we don't. What does it actually mean? People, struggle sometimes with that as well. So serverless is, it doesn't mean no servers. It means less or no management. So it probably should have been called manageless. And that means that you actually do automatic scaling based on observability that you've already created, based on fault tolerance that you already have, and things like that. You can actually scale automatically up and down depending on different metrics. You can reduce your costs of operation by using less hardware or renting less hardware if you're going on public cloud. And if you're not doing that, you can actually still do a serverless. So there are a bunch of projects out there. For example, a Knative is a good example where it is built on top of a Kubernetes on the bottom there. There is some kind of service mesh in between, and then on top of that, there is a Knative thing running where you can do a serverless applications. It used to be Istio as a service mesh. Now it's actually different kinds of those as well. So it can be different options there as well. So it will reduce a cost of operation, cost of your spend to the cloud and all this kind of things, but also will give you less toil because your applications will be more of a elastic kind of scaling thing. And so that's the 5 things that I wanted to talk. But now I want to kind of mention a few things when it comes to the Jakarta thing. To do that, I kind of want to start with it's one slide thing, but I want to start with the old Java EE that it used to be until it became Jakarta EE, and all the things that were followed by or added to that package, if you want. There's a bunch of things, and there's a lot of things that we normally use that, JAX VS, nobody use that much anymore, I guess, but JAX RS are much more relevant. JSON WebSockets, all this kind of things, security stuff. Jakarta 9 was pretty much a namespace transition, but then there is new features and updates coming in Jakarta 10 and so on. But the point is, this is a bunch of stuff that is added on top of regular Java that simplifies your development of your application. A bunch of libraries, as you see here. And then there is some stuff that comes on top of that, again, things like microprofile. But there is also other options. There are like Spring. There are some other things that are implemented in different ways. But the point is, with all of those, and especially microprofile that I've been using quite a lot, you will actually get a lot of those things that you see here. You will get, obviously, containers. You'll get loose coupling. That's up to you to actually implement. But you will get a lot of things like fault tolerance, observability, metrics, configuration, all of those things would be coming to you out of the box using one of those libraries. If you want to use microprofile, cool. If you want to use something else, it will be probably available there as well, which is a very, very nice alternative to writing everything yourself. And when you do that, when you implement all those things, or actually, you remember what I said? You do not have to implement all of them, but you at least implement some of those things. You can deploy your application to, I don't know, let's say Kubernetes, where your scaling strategy will be based on the metrics that you do expose. And then you implement some kind of observability, and then you can actually visualize the call going between different microservices. And you can actually trace, and you do traceability of your application and your microservices within that also pretty much automatically, and by just adding a few annotations to your code. I have another talk that I usually do where I talk more about this kind of things in detail, and also talk about things like feature toggling and all this. But that will come later. Actually, I will be doing it also on this channel in some time this year, a little bit further in time. But the point is, there are options for doing that. Have a look at whatever you're using and your favorite framework. And if you don't have a favorite framework, or your favorite framework does not have it, try to look for alternatives and see if you can get that. Play around and see if you can simplify or port some of the most painful things you have in your project, and add those 5 things that I have mentioned here in one way or another. It doesn't have to be 100%. It can be, I don't know, 1%, 10%, 5%, whatever. But it still will make things a little bit easier for you in the future. At least that's my my opinion. With this, I would like to say thank you. That's all I have of the material of the slides. But I would be happy to chat and ask any questions. If you have any questions, please ask them in the chat, or using Ask the Question button. And thank you all for joining me, and thanks for coming. All right. Do we have any questions?
Thank you so much, Rustam. Thank you. No, what a great and excellent presentation. We thank you so much for taking the time out of your day to present the 5 tips of creating the modern cloud native application. So I just wanted to say thanks again on behalf of everybody that has joined us today. I don't see any questions in the chat or in the Ask a Question section. But I also, I'll give it a couple of seconds here while I wrap things up. We're always looking for people to join and book more Jakarta Tech Talks throughout 2023. So if you are interested, feel free to fill up the form that I will be putting in the chat momentarily. And of course, your feedback is super important to us. So once we end the Crowdcast session, you're going to see a green thumbs up or a red thumbs down. So kindly provide us your feedback and your thoughts about what you think about these types of talks. And again, Rustam, I don't see any questions, but thank you so much again. And you all have an amazing day. Take care.
Bye-bye.
Bye.